Welcome everyone to the next generation technology series. Uh, this is uh, the first introduction to cloud um session, day 2, session 1. Today, the 30th June. Here we are on the faculty development program aspects, and thank you to Vipin from Ramanujan College, University of Delhi, and his staff working with Ministry of Education for the Pandit Madan Mohan Malviya National Mission on Teachers and Teaching. As part of this effort, this is day 2, Wednesday, June 30, 10 a.m. session, and this will be, I am Prakash Ramchandran, and thank you for the introduction by the moderators here. And let me jump on to the topic on cloud. The most important thing, and the audience which I understand is all the university teachers, research associates, and I acknowledge that your time is very important and want to make sure that you gain the maximum out of what I can dish out for you. Two things to remember. One is we are talking introduction to cloud, so my assumption is you do have some basics, but nevertheless I will go through some of them and make sure that even those with minimum knowledge of cloud should be able to onboard to this cloud computing, as well to the intermediate folks who wish to learn more. Plus, I will provide you all the references needed. Having gone through for a decade, working on different clouds, especially the open source clouds, you should be able to get from me in the question answer session at the end all the necessary things you are unable to follow. So let's start with what is cloud computing. So the agenda here, we'll start with what is cloud computing, go into the way how reliable remote resources of digital working requires the cloud, and that how is it perceived as unlimited resource for digital work. Then the concept of virtualization, containerization, followed by the types of clouds and the components of the cloud, how it is perceived as in layers. And then we'll move on to the how do we use some of the developers stack, as well as how do we make it production worthy, and what are the elements, some of the aspects of monitoring and CI/CD, and some HA, but one of the other ones will follow after this my session, and that will be on the site reliability. So I will focus mainly on the digital transformation with the basic cloud, and the next speaker will be focused on getting the operational transformation beyond digital transformation, and that will be Ganesh Hiragowda. So I will leave that portion to him and just focus on the digital transformation and the use cases that appear in government and industry. So this is the whole agenda for 1 hour, with maybe 40 minutes I'll speak, and the 10 topics I'll cover. So let's move on to the first topic here. So first slide, you can see here how cloud has been seen into two parts. A person who is in the 60s onwards up to 2000 will describe the transformation in the information age through the eyes of mainframe to the Y2K, or when the transformation occurs towards the web. Whereas if you ask somebody who is in the industry after 2000, they will start somewhere around virtualization and end up in the cloud native computing in the 5 years, 2015, when it emerged. Of course, different parts of the world grow differently at different times, and some are early, some are late. So therefore, the what's currently in India is more towards the 2015 what it was in other places. So we do see in 2020 much more, but let's just start with first. So here we see 60s, we are looking at mainframe. I will just point the arrow there so you can see that we were in the mainframe era. Then we moved to from IBM to DEC on the mini computers. Then we came with the Intel to the microprocessors. So these are the vendors which have prominently made things attractive for the people to use and simplified as they move. Then came the Microsoft Sun. Microsoft and the Sun, the two competing camps, one on the Windows side, other on the Sun Solaris side, which then turned into Linux at that point, somewhere in the 90s. Then came the networking from the Cisco's, which really proliferated the IP network. Followed by that, we had a lot of cell phones, but those cell phones were more like a feature phones, simple phones. And that was the Nokia when they brought in a lot of mobile devices. And then as we emerged into 95, 96, the Mosaic, or what you call the Netscape came in, and then we entered the Sun Netscape, and this combination along with Microsoft, they had a fierce competition, and we reached a web computing, basically web applications and web-based software as a service types of offerings. So what exactly am I trying to say here is, like we have a wave on the COVID wave 1 and 2, similarly we had a first wave of information age, which started in the 60s with the mainframe, ended in the application service over the web. Or instead of a desktop being used as an application, we started using internet, the network of networks, with application being hosted. And that is when web, it was then called web. And at that time, we had somewhere between 2000 and 2007-ish, all the things changed literally with the virtualization coming in, followed by the infrastructure as a service, ASP services, days you used to call application service, as a application service platform or ASP, where one could use the desktop on everybody's desk. That was the Bill Gates, Microsoft's vision, and which actually matured around 2000-ish. And so I used to call them Teleper Himalaya, if you know what it means. That is, you can bring the whole Himalayas onto your cart. And that was then when we used to call desktop, enterprise on desktop. So your enterprise, whatever you use to work, you can do it on your desktop. But that has moved to enterprise being now in the cloud. And what is cloud? Definition of cloud is very simple, that any resource that you want to access, the resource, when we say, we mean the infrastructure resource, which is compute resource. So you have a calculator, you have a mobile phone these days, you do have a desktop, or used to have something called desktop, and some of the people have what you call uh, some tablets. So there are many forms of devices through which you can access information, and that information can be local to you or it could be remote to you. The first wave was mostly towards having everything at your palm or at your desktop level. The second wave has been moving towards the cloud, and that is post 2000ish. And mainly the focus there was on getting the information from the resources which were in those days it was called data center, and specifically internet data center, so IDC. So the wave was for internet data centers, and that where you locate your resources like your compute, your storage, etc., and then you access through network using the VPN or virtual private network. And those servers were physical servers to start with, then they went as virtualized servers, and then it was sold to people like infrastructure as a service. So you just go and somebody owns it, you don't own it, you just subscribe to it and you pay for it. So pay per use. That is when the concept of cloud entered, with Amazon entering in a big way, and that was 2007 times. Of course, there were other Rackspace and others were there, 2006 years, but mainly they were all still not very standard. Amazon set the first standard with the API, and that was 2007 timeframe. So that is how you got into the resource being available, the computing resource being available in the cloud, and this is where we running with whatever. There was another cloud stack at that time. There are other stacks, but mainly the OpenStack emerged in 2010, and then between 10 and 11, then there was a Cloud Foundry, which was again a VMware virtualization folks got, and along with the IBM, it was more Java based, and this was Python based. And then you got into something called containerization in 2013, and on to the 15 when you got the Cloud Native Foundation being formed based on the Kubernetes, which is the orchestrator for the containers. So let me go to the next slide. I have given you the references here at the top. You can see one, Kumar Swamy, I remember, who introduced me, Subra, in Valley here. He has authored a book in 2008, and that was about the cloud security. Even those days, the terms were very, very new at that time. Then the second wave, which I have put Nikita Raghunath, she has given a full presentation at the last year end hackathon. We have, sorry, not the hackathon, the annual of the Open Technology Foundation, and you can go through those records. It is available to you. So I go to the next slide. Now let's go to what is the cloud and what is the unlimited resource we talk about. So if you look at, there was data processing even during the mainframe days. They used to call it executive data processing, EDP, and data processing and data entry and all. Those were in the 60s, 70s, 80s. Eventually, when the virtualization took, this is around 2000-ish, when you started having a physical server and a lightweight physical server with the hypervisor called ESXi, and then it evolved into various versions, VMware, we had a version 1, 2, 3, and so on and so forth. And eventually it came to a place where virtualization, that is, you have the hardware, on top you have the host OS, and which is a bare metal supervisor, you can call it, types of that, with a hypervisor, where you can have different guests. So I can have a guest kernel over the hypervisor, which is virtualized. Now, what are these? These are all software, basically software dealing with the hardware. So your hardware is generally the CPU, the storage disk, and the network gears and all that. And when you have an operating system managing those, that's the one which deals with the multitasking, cooperative multitasking, and time sharing, and all those aspects of it. If it is single host or multiple hosts, depending on how you configure the network. The third, of course, the hypervisor layer is the one which is virtualized over a given host, which can then be used by multiple operating system or multiple guests. So you can have a ESXi host example, a hypervisor. There are many hypervisor, one of them being this. Then you can, KVM is another. So if you have those hypervisor, then you can, on top of it, you can have a guest kernel. And so that guest kernel is nothing but a full kernel which appears to the user as focused on their particular requirement, like a guest OS. Like guest OS, one could be using Sun OS those days, the other could be using Linux, third could be using Windows. So each one with a different application, with different languages. They were called as virtual machines, and that could be used. And you have reference here. I have the packet book containers in OpenStack by Pradeep Kumar Singh and Madhuri Kumari. Both of them are in India, and Madhuri is one of those prominent speakers at many of the places in OpenStack. So you have a Kindle reader which you can use, or a Google Play probably, and go through that. It has got immense information for you to absorb on virtualization. Let's go to the next slide to little bit deep dive. So virtualization is nothing but kind of projecting the resource to the application, as well as application can itself be virtualized. So what it means is, it's a question of layered. Two ways you can look at it. One is the layered approach, which we spoke earlier. We can also look in terms of containerization, in the sense that VM is itself a container, but that's not referred as container. It is, you have a VM is virtual machine, and within virtual machine you can have run the application. That's what we saw in the previous slide. Here what we are saying is, we have a hardware, we have the host. Now we have eliminated here the hypervisor. So the container is a runtime which runs directly over the host, and a single host, and you have the container. So containers then will have to be built based on some of the concepts of kernel. Like host OS is a namespace. It has a what you call security group, and it has got a some kind of a C group, we call it. And where you specific characters you can use, like what kind of resources do you want to isolate. So C group is for isolation by CPU, memory, network IO, disk IO, whereas namespace is, as you can see, for the network, file, process, and IPC. So IPC is inter-process communication. So at a host, at a OS level, you have processes. And so when you have processes and the file handles, that is the inode and whatever we call it, those are used as mechanisms to address the files. So you have a file handle, etc. Inter-process communication. So essentially, if you go into deep dive into that in the Linux container, a domain, LXD like domain, like you see on the right side, is the one where you are able to either using the libraries which are there for container, libx, you can see container library, or you can also use Docker, which is the most popular one amongst. And so basically you have at the command line, you can create a namespace with the C group and security and create an image and boot the image, and that gives you the container. And within the container, then you can run the application, or you can even include the images within the container while booting and automatically start during startup, etc. So mainly we have to see that container is a different footprint than VM. VM generally can be used for multiple applications, and container is preferred that you run one application per container. It is much lightweight compared to VM. So the concept of VM and container is important. So I would say look at the references, and there are of course different OS operating system. The open source operating system we would suggest will be obviously a Debian flavor or a RPM flavor. So Debian flavor is usually Ubuntu, and it uses AppArmor as the security mechanism based on applications. That is the application access read write execute level. Whereas RPM is the Red Hat package manager. RPMs are again source like SUSE and Ubuntu and Debian and all those, and also CentOS, but the life cycle of each of these is at different stages. Just I would recommend here that you can look at the references, at least the next one. So at this stage, we are almost 20 minutes into the presentation. So I will get on to the nitty mobile phone or whatnot, so the tablets and all. Now these cloud, you can have a data center in your garage, which is what a lot of people in Silicon Valley do, and or if you are not sufficiently able to get resources, you can directly use it from the, which is what the idea is of the cloud, to have some managed data centers and co-locate. Either you take some servers if you are an enterprise. If you are an individual, you just take one VM or one container and then log on to it. So if you do that, then the question is, what type of cloud is it? So there are classification as private cloud. So for private cloud, most of the people tend to use OpenStack. If it is commercial, they use either the VMware or Red Hat or some of those distributions. Now, the OS also has a distribution. Even the cloud operating system or cloud service have their distributions. So if I say OpenStack distro, it means you are looking at the private cloud distribution. If I say just a host with an operating system like a Ubuntu, then you are trying to get just a data center with access to the public cloud. So you can have a public cloud and private cloud, or a hybrid cloud combination thereof, or you can have a community cloud, which is the government clouds example, or a university cloud. So as a university professionals, I think you will be more focused on the community cloud. However, because you cannot build everything on your own at your own expense, you may want to subscribe and get. So you may use public or private cloud or hybrid cloud, as may be the case. So what's the characteristics of cloud and how is it distributed? So clouds generally are categorized as they can be, you can get the resources on demand. They can be elastic. That means you can scale up and down, having one server, two server, no server, or you can have containers or VMs. So that is the compute part of it. Then you can also get storage. You can get a storage for what do you call, 10 gigabyte or maybe 100 gigabyte, and depending on what kind of storage you want, what kinds of catalogs you want to maintain. Then other thing is multiple universities can be using the same, or within a university there can be multiple departments they can be using, and within the multiple department you may have a user, a research user who is using you can, whether it's a private, public, or hybrid, you can share it, and that is why the cloud is the cost of the cloud is brought down by sharing. And when you share, then you use thousands of students participating simultaneously on a single uh, session, then you should be able to stream. So there is a multiple stream requirement. So the size, capacity, all that can be on demand, and you can subscribe, you can pay per use. So those are the main concept of cloud. If those are satisfied, that's what matters, and that you can go back to Subra, whose first reference I gave earlier on the security, cloud security. He has a fantastic presentation there, and as well you can see on the other references we have here, like you have the OpenStack reference here. So this whatever we see, what it tells us is that we have private cloud, which is generally used for um, uh, for the enterprises or campuses or example hospitals for the healthcare, and so any department. So private, if you don't want to share anything to outsiders, you want to keep data protection with privacy, etc. So usually, if you have finance and all, you tend to keep it private. But then it's a question of cost. So if you want to reduce the cost, sometimes are also question of how much time does it take you to get an OpenStack running with all the hardware ordered, and if it is going to take months and months, you can't wait for 3 months and 6 months before you get and then start working. You can as well start on the public. So that means time to do your work. You can develop in public and then transfer it to private. So essentially what it means is it is all the characteristics that define shared infrastructure. Multi-tenant is easy, it is multi-site, so you can get from anywhere. So if you are collaborating with people from Delhi, with people from Chennai, then you may want to take a public cloud to start with, and then after all, once your data center is ready and you are able to share and set everything, which may take 6 months, then you can move back from public to private, and that is where part of it which is not mission critical, you can leave it in public. Then you can bring those which are critical, mission critical into private. Or it could be the other way around. Mission critical may mean that it has to be available all the time, and the private one is not 4 nines or 5 nines availability which you need. Then you may, it's all context based. Depending on the usage context, it that is the best practices. And you can also note that we had in the beginning itself, we said that the two eras, one is pre 2000 and post 2000, wave 1 and wave 2, I said. So information age, wave 1 was 62 to 2000, and 2000 to 2020 and 2030s we are going towards. So we are looking at you can say that if I have one bare metal, I can have 10 virtual machine, I can have 100 containers. So something out of the order of, it may be less a little bit, but at least to the extent 110, 100. So if I have a data center with 1,000 servers, then you can say I can have 10,000 VMs and approximately 100,000 containers. So it depends on how much you use in your universities. You have to plan the capacity, and accordingly you can use the resource, whether it should be budgeted on the buy versus lease option, which you always have to go through. And then at the top you can see there are various OpenStack SDKs there, which is usable for using the modules that are there. And Horizon is nothing but one of the modules, which is a user interface module. So you have a dashboard in it which can be using to manage the OpenStack. Either you can use command line or you can use the web-based dashboard. And so that is one. And Terraform is similarly a management scripts to be able to manage OpenStack, or you can use some specific Google Cloud, or it could be any. So there are no restrictions these days, especially all scripts are available. And if you go to the lower portion of the OpenStack, you can see there is a entire set of modules being shown. So if I take one cloud example, OpenStack Cloud, what you see here is the layer. And of the layer, the red one, which is there pointing to Neutron, the compute is the NOAA. So when you have compute interface, and that is called as NOAA, what does it do? It has an API, bunch of API. Like you can have a CRUD or create, read, update, delete, conceived that at that time it used to be called API. These days you can call it as microservices because it focuses on one object. Example, NOAA focuses on compute, Neutron focuses on network, then Octavia is a load balancer. When you get a lot of sessions, you need to allow balancing of the workload which people use over the compute as well as over the network. And then obviously designate is nothing but a add-on, and that is for the DNS, which is equivalent to your bind or anything of that kind. Swift is a object storage. So you always need some object storage in a cloud so that you don't use the local file system, you use the file storage, which is, or you can use file storage also, like Manila. And then you have Cinder, which is for the block storage. And then you have Ionic, which is for the bare metal provisioning and all that. And you've got Cyborg, which is mainly for the GPU and what you call the accelerators and all those which are upcoming. And at the top you can see the dashboard. You can have a Horizon or a EC2 API because the OpenStack always started with the EC2 API. Now how many versions there are? A2 it has come to X Xena version. So you can see how many versions are there. Most of the people are on the train version T, and they are moving towards what you call either the UVW maybe, and maybe V Victoria. So it depends on, each one has a name, and then the releases are there. The release portion is all shown in the link. We'll go into that. So what we see is you've got all kinds of services. The bottom one is very important, global services. Keystone, that's the one which deals with the identity management. So if you have to do multi-tenancy and all that, you need to focus on Keystone. And the endpoints that are available to you, endpoints are nothing but a URL, which is www.something.something, which is the web URL, and then you can connect from there. So that is important. So all of these modules which are there, they do have what you call web-based access. And on the other side, on the operations tooling, I leave it to Ganesh, who will be handling that. And you can have client tools as well as integration enablers. Some of those are like a client for the, like you say, Python SDK, and similarly OpenStack client. Usually a client sits, if you are going to remote manage an OpenStack, then you must have an OpenStack client Python library, and that through which you can do it. Or you can also have a web-based Horizon installed on your end of it so that you can manage it. So administrators have to deal with all the role-based access and all, which is part of the Keystone. And the one more important most thing is Glance, which is image creation. So if you want to do any image creation of a VM, then you have to use the Glance, at least for the OpenStack part of it. And you can have other Barbican is security, and placement depends on where you want to place your workload, etc. So we have covered OpenStack in a broad sense, but you have to deep dive into it based on the timings I have to move on. So I will show now the next the portion. We assume that cloud you will be able to read, and it has the links are here provided for you to see what are the releases available to you, and you can also go to the marketplace for the distributions that are available commercially, and also look at the Ansible portion of it, because that's the one which is more mature from point of view of automation and management. I will talk about the DevOps and a little bit of the production and the DevOps portion. DevOps stands for development and operations. These days, developments and operations are required to be done by individual. So if a developer says, hey, I don't want to care about operation, that is not my job, that's not true. You need to know how to deploy your at least you have to walk through. If you are only an application developer, that is different. But if you are you need to build your own images for distribution, then you need to know this. So here what we are doing is a workflow, and this workflow shows how to deploy a Ansible, OpenStack Ansible installation. So you prepare the deployment host. So you have a host, you have to know what is the specification of the host, how much of memory, how much of CPU, how much of disk space, and you have to prepare a bill of material and make sure that that is listed in your, in this case, because you are using OpenStack, it will be Heat. So Heat is used for deploying the stack. Heat is a orchestrator for OpenStack. So what you do is you will prepare the list and provide that to the Heat to deploy the configuration. And this configuration will be in a what you call a declarative YAML or a JSON file, what you call, and simple file where you put down the various elements of the host as well as any application you want to implement on top. So there may be sections for hardware, there may be section for networking, storage, there may be section for application, could be for a multiple, could be for database, could be for web. So all that you describe in a descriptive file, which you then provide it to the target host, which can configure and deploy those, whether you are doing bottom up, that is from infrastructure as a service, or if you are doing only the application deployment. Either way, your process will be very, very similar. You just deploy the host or deploy to host and the target and specify every specs you need. Once you configure, you deploy, then you run the runbook and it will keep running, and then it will show you. You have a Ansible playbook shown here in the YouTube. You can watch that. So DevStack is a stack which was used as a development stack for development of OpenStack itself. Now, how people started using for proof of concept and development, but essentially you can use it, but I would not recommend that for using it as a production distribution. You have to look at production distributions that are available, and you have to build your own. That is the best thing if you want to have customization. Like you may need a different, like Delhi University may need something different from IIT Bombay or IIT Chennai, or it could be IIT Madras, that is, and then it could be different in maybe at university, in different university in maybe in Gujarat or in Maharashtra or wherever. So depending on the need for you, you have to define your resource and define your BOM, define your application, and also do a high level, what you call the planning to know uh, what is that you want to achieve at the end of it. Is it a research experiment, or is it just a administrative host, or what kind of cloud you are looking at? And if you have multiple, how do you define your data center? So there is a program, Vivek Vishwavidyalaya Anusandhan Kendra, which is what we have been working with Delhi University, and hopefully that will show you how that can be. We can show you that at a later stage sometime when you have got some hang of what we are looking at. So this is one. I will move now from base stack to distribution. Distributions are there in the marketplace to using CI/CD pipeline. When CI/CD means continuous integration and continuous deployment. Before we go to CI/CD, just for the sake of completion, here we are talking about the production. And when you say production scale cloud deployment, then you need to know that it's not simple like your just take a GitHub and download something and just install it, but you need to know the concept of high availability. That is how many, what's a kind of copies you need to keep so that you don't lose anything. There is no single point of failure. And then how do you do it? If you have an example here shown is a HA proxy, that is the load balancer, and that is balancing the loads of MySQL, which is nothing but a database, and you can use 3 of them here to ensure. You need some quorum so that if one fails, the other takes over. At the same time, you don't want any split brain. Basically, that means you write only in one place and not in the other. So that is the possibly, but essentially, hopefully, you have. You cannot add any tenants or any application. You can run what is existing. So there is a whole process here. This one shows with the keystone and the glance being run. So this is also, there are 2 parts to it. One, either you do active or active passive. This is showing active passive. So basically it means that keystone and glance are stopped in the controller one. And the concept of also, you have to have 4 planes as usual. Control plane for controlling, management plane for managing the infrastructure, as well as managing the whole dashboard, etc. Then you need to have what you call the user plane or data plane. User plane is the client side of it, which aggregates and appears as data plane, or the workload. In this case, we call it as the compute servers and network server and storage server. So depending on whether you have a stateless or stateful application, you need to use the monitoring to ensure that any failure is reported. And that site reliability engineering portion, I will leave it to the next speaker who will be able to detail it, and Ganesh should be able to do justice for that. So this just gives you a picture of what is required for hardening. And we are only talking provisioning here. The other than that provisioning, like day-to-day operation, that I will leave it to Ganesh to handle. So let's now move on to the last phase here. Here what I am showing is a bit of more to do with the CI/CD, because a CI/CD starts with control. That is, if you have a file, a project, and you have a bunch of files, you need to have versions and you need to put it in a directory, and then you have to make sure that it is in a staging area, and then later on you commit so that that can be used by everybody. So this Git or JIT, whatever you call, was the Linux operating system ran into issue in 2003 when Linux Travel found that the bit the version control he was using uh, was becoming was becoming expensive, or at that time it was becoming proprietary, or somebody had taken over, and so he wrote his own. And this Git or JIT is a beautiful application which you must master if you are a developer. For all developers, you need to know what is Git, what is the master copy, what is the staging snapshot. And example, here you have seen the red master copy there, and the previous branches are nothing but you have first you begin, then you do patch, then you move to from left to the right, and then your master at a given state can add more branches like CSS, and crazy branches are being added here. Crazy was pulled from the one before the master. So wherever you have got versioning, you may have 1, 2, 3, 4th box there where the crazy is being pulled out. Our new branch of crazy is pulling out of the 4th, whereas the master currently is at the CSS. So basically, important thing to remember is every version is maintained and only difference is being added. So it is image basis, difference basis. And this is very important because how do you manage otherwise? You can't keep on loading every time a new folder with a new, and then who will manage it? So management is a nightmare if you have got volumes like Linux, where you have millions of lines. What are you going to do? So same way your project will start small, but it will grow. So always use Git. And then a Gerrit is a review code reviewer on top of Git. So you'll have a Git at the level of command line, and Gerrit you can have as a user interface, or GitHub you can have it, and over which you can review the codes, and multiple users can submit their code. And the project, so this is a distributed version control. That's the key. The message here is you must go through, and we will definitely have you review this, because this is nothing but build. So one is you do build, and this is you can do manually, or you can do through tools like Jenkins. So Jenkins is a tool which is a user interface where you can have a build script, you can have then deploy script like you do in your coding. You do a make build, make configure. Same way, these are all automated, and that is what is important portion here. So you should go through these two links which are there for your reference, so that you can go through that. So Jenkins So you have a declarative pipeline which shows that a Docker image is being pulled in and it is being built, and then you are executing it. And same way, Zool is another one. So Jenkins is the one which was 2010-11, and it came in and it became popular. And then over a period of time, many more came. Even Jenkins itself has many new versions. But one of them which was adopted by OpenStack was Zool. And Zool has certain advantage, and here you can see the on the right side how you can manage different projects. Either it manages independent or dependent. What is the dependency? What are the serial deployment? Either you do parallel deployment, and so basically it's a number of jobs being fired together, and one by one, or in one depends on the other, and plus what is required. So Zool is nothing but a project gating, and German is the server which they call as the one which manages that, and Zookeeper is the nothing but it is able to protect failures from one to another. The scheduler is the one. So node pool is the bunch of nodes are available to you from which the scheduler will pick up and schedule the job on that particular host, and accordingly the job will be executed, and that will be patches will be reviewed by Gerrit through the GitHub, and then you can see that what is the merge. So you have to merge the patches using Git and all that. So you must know what is patching, you must know what is merging, and what is master, and how do you manage the master, and how do you manage the version control and all that. So these are important portion. We are another 10 minutes away from our closure, so I will just give you a final thought on the what should we expect from you. So as a university educators, we expect you to go through all the material that is provided to you here in the references and a use case for India example. So example here we have MITI, Ministry of Electronics and so IT. And so what we have here is a proposal here for CSPs in implement, they call it, which is like they want to onboard new CSPs or they want to onboard the new services of the CSPs. So what type of cloud the government of India is interested in? It's a public or private. So what I'm trying to say is, as an educator, you can review the document which is there provided to you for the CSP application implement of the CSPs and answer the question. So this is like a case study for you. You can go through, find out what types of cloud government is public or private, what are the 6 domains that they are interested, whether it's a compute or whatever. So look at it and find out what the answers are. And can a startup apply for this opportunity? Yes or no? Figure out what is the level of finances required to do that, etc. Then you can find the what are the data center offering? Is it capital intensive? Is it operational intensive? So what is the expected gross revenue for 2 years, etc. And so on and so forth. So there are a bunch of sections there, you can go through it. And what is the meaning of SLA? So it's nothing but service level agreement, but you have to explain what does it mean. So that's what we expect you to go through. And what is different between managed services and do it yourself? So what do you get from the cloud service provider? And what may be the reasons for lack of data centers in secondary cities, rural locations like in India? Why is it? And then why is there more that virtual private cloud, or whether you want a public like AWS or Google, and what are the rates, and those are the things which would like you to understand. And do you think that AWS or Google bid for this? Essentially, we want to know this. If you read it, you will know why and who should be doing this. And to end, this is my last, hopefully, the slide to tell you that digital transformation has taken off around 2016, and that is when the government actually started using the IT. The e-governance was there in 2003, 2004 at the state level and all that, but at the national level, once the Aadhaar got established, it became easier. And then really utilization of Aadhaar to the maximum by this current government has really led to the usage of cloud in the Ministry of Education, Ministry of Health, Ministry. All the ministries are now currently using the effort, and to 20. Then you got the 36 state and union territory having those clouds, and they have got all the applications. And based on that, and based on the goals of the what do you call the United Nations development goals, sustainable development goals, India has been monitoring it, and they definitely our government has done a great job. And our ranking in digital usage that is the world competitive rating of ours ranges in from 56 we have moved to 44. And so what we see is, of course, it has been positive. The COVID definitely did have some impact, but essentially we are based on knowledge and technology, and our readiness is very good. And we need to improve this for 2030 to reach the 10 trillion uh, goal for the GDP. We are at 3 trillion. So we believe that this series which we are conducting is to enable you to help India, and especially help the students. Being teachers, you are the means for us to reach them, and we are very happy to see that you are attending this, and this 12-13 days you will have massive learning, and you should be able to take this and apply it. And so our goal is to see that we go by facts and not by what you call, if you don't measure, you don't know what you're doing. And so we have to measure, and this is the efforts on the government's part, and we should be able to leverage this. And we have volunteers all over trying our best to make sure that you receive the best and the best of the what we can within our limited resources. And definitely we look forward to your embracing the cloud. And I hope I have done justice to my 1 hour what you call preaching to you. It's said that Guru is important. So Guru Devo Bhava, they say. So hopefully if you need anything, we are here to support you in all your efforts. And Government of India is also very much with you. And Education Ministry especially, I should thank them for opportunity for me to give you this speech to you. And thank you very much, and Jai Hind. And you can start your questions. Also, you can reach me at this email if you need any support. Thank you very much.